It looks a little bit stretched, right? Or compressed? It looks a little bit compressed. Do I have to change something with the setup? The recording and stuff is.
Oh yeah. You guys, everything okay for the recording? Okay.
All right. Can you hear me? So welcome to this talk, which I titled PKG, Project.toml, Manifest.toml, and Environments. So the background to this talk is something like this. So if you go to the Julia discourse, there's basically a daily question about how projects work and things that go wrong. So this is my attempt to address some of these questions, and maybe I hope you find it useful. And for you that attended the workshop yesterday on PKG, this talk is not so much about how to use the package manager itself, but rather how to use environments and so on. So it shouldn't overlap that much. All right. So the agenda. So first I'm going to talk about what's a project, and that involves these two files, TOML files, Project.toml and Manifest.toml. And next thing is how they interact with code loading. So basically what happens when you type using data frames or whatever. And that uses a variable called load path, which you might have heard about. And then lastly, I will show some examples on what you can utilize environments for and so on. And if time allows, I have a teaser for a new feature in PKG, but we'll see if we have time. All right. So what is a project? So a project is basically just a pair of these two files. So it's a Project.toml file and a Manifest.toml file in some folder. So by default, if you haven't explicitly worked with environments yourself, then you are using the global default one, which is located in your home directory in the .julia directory under environments, which is basically what you modify when you add the package from the repo. So projects are basically free, so it's just two files. So you can use them liberally. It doesn't really matter. All right. So is a package a project? So in the new era of Julia 1.0, each package has a Project.toml file as well, right? So a package is a project, but needs some extra features, you could say. So a package needs also some extra entries. So it requires a name and a UUID. So then it's a package. So that's how you can differentiate between these two. So Project.toml. So the project file describes kind of the high level information about the project. So in particular the dependencies of the project, which is basically what packages you have installed. And the project file also includes compatibility constraints in a compat section. So for a package, the Project.toml file also defines then the name and the UID of the package. So the project file is also what we as users interact with. So usually we do this through the package manager itself. And you can also think of the project as the input to the package manager resolver. So for example, if we're trying to add the package example, so the input to the resolver is the current project. So we might already have some packages installed. And then we also have input to this new package that we want to install and the current Julia version. So you can think of the project as kind of like the recipe or the input. All right. So usually the project file is paired with a manifest file. So the manifest file it describes the absolute state of the project. So in particular, it includes the full dependency graph with both direct and indirect dependencies and exact versions of all the packages in the environment. And you can also think of the manifest as the output from the resolver. So basically the result of what versions that we got. So for example, then again, if we try to add the example package, the output is a new dependent graph, and in particular, a specific version for the package that we added. So this is something that's I think is somewhat confusing. So if you add a package, the package Manifest.toml file is not used. So sometimes people get confused because a package may have a manifest file with some specific version of packages, but then in your global environment they are not used. So only one manifest file is used at a time. And lastly, the manifest is machine generated, so you shouldn't really edit it yourself. All right, so that's the two files that describes an environment. The next thing I want to talk about is load path. So the load path defines a stack of projects. So by default, it looks like this. So it's an array of strings. And the first one is just an @ which is if you have selected, if you explicitly activated or selected the project yourself. And the second entry is what you get by default. So it expands to the current Julia version. And the third entry here is the Julia standard library, where the standard library packages is located, so like random and test and linear algebra and so on. So we can look at what this expands to. So there's function base.loadPath. So by default, you get something like this. So in this case, I have not selected the project specifically. So the first entry with the @ sign is empty, and we only got the default environments here. So version 1.1. And then here was the standard library located. So you can, of course, modify the load path yourself from within Julia, or you can use this Julia load path environment variable. So usually that's not something that you have detached, but it can be useful in some situations if you want to modify this stack. All right. So if you just go back here, so the first entry here, I said it was expands to if you have explicitly activated or selected the project. So to activate the project, you can either use, there's a package command called activate, which you can use. So that's what we pick by default if you have an active project. But you can also set something which is labeled the home project. So that's what you get when you use the -- project flag to the Julia executable, or if you set the Julia project environment variable. So for example, if I'm developing a package called X here, and I have activated that one, so then the first entry is now expanded to the path where I have this package. And then I still have the stack, so I still have the default environment in the second entry and the standard library in the third one. So next step is code loading. So what happens when we type using X in a REPL, for example? So first, we have to look up what does X mean, or in particular, which package is X. So then we go through the load path, the entries there, and we look for, can you see that? It's very dark, but anyway. We look for a deps, or we look for X, the X key in the deps section. So we just look at load path, the first entry. If we don't find it there, we move on to the second one, and so on. So what that gives us, if we find it, is the UUID of the package. So then we know what is this package, or what does X mean. So when we have the UUID, then we go to the manifest. And then we look in the manifest for this UUID as a key. And in the manifest, as I said earlier, in there we store what version and what dependencies, for the dependency graph. So then we know implicitly where X, or where the source code of X is stored, since we know the version. And we also get all the UIDs of X dependencies. So then we can go back and look for the versions of them in the manifest. And then finally we load this, the module where the X package is defined. So what is then allowed to using or importing? So from a top level, so if you are in the REPL, then we can load anything that's found in the depth section in a project file in this stack or in load path. And from inside a package, then we're only allowed to load what that package defines as its dependencies. So in the package Project.toml file, there's also a depth section where you list all the dependencies. So that's what you're allowed to use. So in particular, in the default setup where we have the stack with the explicitly activated project and then the global one, it's possible to load packages from, let's say, the second entry. So I think this is very useful for package development. So you might use, for example, the revise. You don't have to add the revise to the package as a dependency. It's enough that it's available somewhere in this stack. I will show an example of that later. Oh, actually now. Okay, great. So this is an example of how to utilize the environment. So for package development, so usually if you're developing a specific package, it's very useful to activate that environment and work in that environment as a development sandbox or whatever. So for example, if I'm working on the example package here, so that's my first entry here, so that's something that I have explicitly asked for. And then we have the global one. So for example, I can load the debugger from the default one and the example itself from the first entry. So let's just, oh, this is very small. This is readable. So let's just start Julia. So we add the debugger here in the default environment. Like that. So the debugger is available from this project, which is the default one. And then if we go work on a package, the example package, for example, I have it here. So if I specify, I want this project as my home project. So now, if you just look at the status here, this is now showing, it's very dark, but the status of the example project itself. So then, can we load the debugger, which is in another environment? So let's try. It seems to have found the package and precompiling and loading it. So what happened here is that debugger was found in the second entry here. right? So I installed that in the global one. Okay. And then the package itself is, of course, available from the first entry, which is my explicitly added product. So now we can use functions like from the debugger, what is it called? Example.hello, JuliaCon. So then we enter the debugger. So I think this is a very useful setup when you're developing packages. There are some tools which you are often using, like the debugger or revise or benchmark tools or whatever. And you don't have to install them in each project you're working on. It's enough that you can find it somewhere in the stack. So that's at least how I do package development. So the second example here is something I labeled task-specific projects. So since a project is very cheap, it's just 2 text files, you can use them freely. So I often find it very convenient to just create if I have a task to do, then I just create a new project. It doesn't cost me anything really. So for example, for building documentation, if you're using the Documenter package, this is now what we recommend for that. So let's just look at that setup. So now this is one of my packages. So in the docs folder, we have a specific project here. So in here, I have dependencies. So for the specific task of building the documentation for this package, then I want a Documenter package. And of course, the package itself, and then I'm using plots for generating some plots when I build the docs. So this is a project which is just specific to one task, right? So I just want to build the docs. And I also have the manifest file here. So that means that in here, everything is recorded about this environment. So in particular, the versions of the packages and so on, and all the dependencies. So this makes it very easy to reproduce. Since I'm saving all these, so it means that if there's a new version of a package, it will not break my build of the documentation because I'm using these specific versions that I know is working. So this is I think, pretty nice example of creating an environment just for a specific task instead of cluttering the global one. Let's go back to presentation. Where did I have it? Oh. Right. And another example is something I labeled an application. So, as I said earlier, for a package that you're supposed to, as a user, use, and you add it and you use it for some functionality, then the manifest file is not used. But for an application, it might make sense to provide a manifest file, so then you can create the exact environment. So 2 examples of this is documentation generator, which I thought did this, but apparently they don't, so they should do that. And at least one example is registrator. So registrator is what the app that's running the registration for packages. So if you want to start your own instance of this, we provide this manifest file here, right? So we know that this one is working, these versions. So for example, binary provider 0.56 or data structures 0.17 and so on. So this makes sense for a top-level application. So I know that my users here will use the exact, or at least I give them the opportunity to use the exact environment that I, as a developer, used. And apparently the documentation generator package does not do it, but I would recommend doing And the third one, or the fourth one maybe, example is for reproducibility. So it is enough to store these two files. They define the full environment. And if you have them, then you can reproduce the exact package environment, for example, a year later or on a different computer or whatever. So this is very useful for many reasons. But for example, if you have some research project and you have some code and then you get back a review and you need to modify something, then you know what packages you used and what versions and so on. So it's very convenient. And it's just two files, so it can easily be stored. So for this to work, as we saw earlier, it is possible to load packages from other entries than the top one in the stack, right? So if you really want to be able to, if you want to be sure that these two files capture the full environment or everything that we are loading, then we actually need to modify the load path to only have one entry. So let's just show that. So I have a research project here that I made up. So I have the two files here, manifest and project. So you start Julia here. So I have a couple of packages that I added. So I have data frames on which I added on master, the GitHub package on some specific commit, and then some other packages on fixed versions. But in this environment, I can still load the debugger. And maybe you don't want that, because now we depend on something that's lower in the stack, right? So then these two files in my research project, they don't capture the full environment. So you can modify the load path in that case. So I'll just do it by modify this environment variable and set it to this directory. So you start Julia now. Oh, you shouldn't just, JuliaCon, research project. Okay, so if you start Julia here, what did I do now? Oh, this is the wrong window, right? Okay, so now we're back here. Let's see. So now the load path, I modified it so I didn't, okay. Wrong window again. So now the load path only contains one entry. So this is the only thing that we can use now. So everything that I'm typing here, so for example now, the debugger is not in my research project. And the research project is the only entry in the load path. So this will now error, because we cannot find the debugger in any of the stacks. So I also said that it's very useful for reproducibility. So let's just go into the Julia directory and remove all packages. Like that. So now if you start Julia, the status output shows, I don't know if you can see them, but it's on red arrows to the left. It means that the packages are not available. But we still know which versions we want, so it's possible to instantiate this project. And now it will look in the manifest and project file and download all of these versions. So now I reproduce this exact environment. So this is very useful for research projects and so on. All right. So that was my talk. So I don't know what time it is, but 5 minutes. Okay. Thank you.
All right, thanks for that talk, Fredrik. Does anybody have any questions for Fredrik about the package management? Why don't you come up?
Hi. So in the default setup, standard library was in the load path. When you change the load path to just the current directory,
Yeah.
so you can just be in your project.
Yes.
Would you still be able to load standard library packages, or would you need to explicitly add those to the project?
Let's try. No. Then you have to explicitly add them as well.
Okay.
So I think this is a pretty useful property. I mean, you can add standard libraries to your product as usual. So add test, and then now that is also recorded in the environment, right? So now we can use it. So
And if the standard library API changes or something, that's going to have a different.
Right. So currently, that's one thing that's probably have to change, because currently we don't record the Julia version in the manifest. So that's something you still have to use the same Julia version, since currently the standard libraries are versioned according to the Julia version. So,
Okay.
Yeah. Thank you.
So I'm not 100% sure on it. Can you stack the Projecttomls and for how deep, right? So say that you have a basic functionality that you always want to have available, but there is, for learning a model, for instance, you need some additional coding. You depend on some very large dependencies that you may not always want to install.
Yeah.
Could you do that with task-specific projects that you layer on top of your, say you have a base package and then for...
Yeah, sure.
Yeah, okay.
So that's basically, I mean, in this setup where I can go back to that. In this setup, right?
Mm-hmm.
You can basically think of the second entry here is like the global one, so I always want to have available, and then the first one here is some kind of task-specific project, right, for developing this package. So yeah, and you can of course modify this and include more.
And you would just achieve that as well by doing like activate in after each other, or?
Yeah. So by default, the load path looks like this size. So there's only one entry here for like you can only have one activated project, you can say.
Okay.
But you
so need
can
to
push
adjust
entries to
the load.
the load path. Yeah.
Okay, cool. Thanks.
Hi, just two short questions for you. The first one is, I think we talked about this before a little bit, but to what extent is the Project.toml like an open format? If you wanted to define new sections, or like for a package compiler or something like this, what would you recommend the best way to go about it?
So I don't know actually. So currently the package manager only cares about the dep section and the like name and UID and stuff like that. I think it doesn't remove stuff if you have added like your own section. So you could use
package.toml, I guess. And
yeah.
And then the other one is, if I switch environments, does it also invalidate my precompiled caches, or?
Probably, yeah, but packages that you have already loaded in that Julia session. I mean, if you have one environment and you load the example package version 1, and then you change environments where in that environment example package is version 2, for example, then you have already loaded the first version, so that will not change, of course. But yeah.
Sweet. Okay, thanks.
Thanks for the talk. You had some version numbers in your manifest file. Are those packages pinned, or are they just part of the manifest file?
No, they're not pinned. You can of course pin them, but then we'll also say explicitly pinned.
So what is the difference between pinning and having just the version numbers in there?
So pinning is if you want to disallow updates, for example. So you can, if you use the update command, if you have some package that's pinned, then that's fixed, right?
Yeah. And if you have a pinned package in your manifest file, and if you're a package that is added by some other package, you said the other package does not use your manifest file, so it probably wouldn't pin the dependency.
No. So if you want to restrict for a package, if you want to restrict some specific versions, then you need to use compatibility constraints instead.
Okay.
Yeah.
And if you wanted to use optional dependencies, is there a way to do that?
Not currently, no.
Okay. Thanks.
Hi, I have two questions. So how are you supposed to use the resolve function? It's something that I kind of commonly find is that if I'm in a package and I add a dependency, I'll get the warning that it's not in the main environment, but the resolve, I feel like I'm never using it correctly.
So I think of the resolve function as basically synchronizing Project.toml and dependencies with the manifest files. So what happens if you have added a dependency but you haven't resolved? Then you might have to do that because your package in the manifest file, for example, your package does not depend on your new dependency.
And so which environment should the resolve function be run?
In the environment that you're actually running code.
The environment that that the issue is occurring in. Another question, once you activate an environment and you run kind of, GC or something, it seems like that's always going to be in GC. Is there like a way to remove and activate?
You can remove, if you delete the file.
Delete the file.
Then it's excluded from the GC,
Yeah, okay. Thanks.
I think we're going to have to cut it off there for questions.
Okay.
Time for the next talk to begin.
Thank you.
So the next talk is going to be presented by Rory Finnegan.